Hello everyone, this is Charles from Surefire Engineering, and today we're going to do a little video on improvisation and adaptation. So we have a project where we've been asked to build a special distillation machine. Now the customer has not committed yet, which is often the case, so they would like to see a proof of concept, and we have to make it on our costs. So what that means is we need to build a small functioning prototype as cheap as possible. And in order to do this, I had to raid the scrap pile to get some raw material and collect pieces that I know would work, that we could put together to build this proof of concept. Now, it ain't going to be pretty, but you know, pretty things only win beauty contests. What's important is that we can prove our concept and then go ahead and scale the design. Now, what I'm making here is an end cap for a type of condenser that we need. We recently started designing and building distillation equipment. It's a little bit off on a tangent from our usual thermal processing machines that we build, such as precision furnaces, kilns, and layers. Now, what I have here is a piece of stainless steel. It is 1.4301, or in the United States, I think they call it 304, which is a mild stainless steel. This is a drop from our laser cutting operation, but as you can see, it fits perfectly on the end of this tube, so I can use it to cap this tube. Sorry about the focus, I'm using my phone here, and it's a shop phone, so it's about wrecked. So anyway, I need to drill a hole in the center of this that is about 22 millimeters in diameter. And our milling machine currently has a setup on it that takes about 2 hours to reset up, that I do not want to tear down. So the option that we have is to use our trusty magdrill here. This is one from China. There you can see the company. Whoa, something just fell off the bench. No worries. So this is our trusty magdrill here from China. We've had it for over 2 years now, and it wasn't very expensive, and I have to say it is an excellent model. It's really doing the job. So what we're going to do is we're going to use one of these step drills. Now these are available in Korea. This one right here is made by a company called Smato, and it's made from M2 tool steel. It's hardened. They're pretty low cost. And the nice thing is, if you have a surface grinder, you can resharpen them yourself. All you have to do is dust along this inside surface here, and then this surface. I have another one here that we've had for about 2 years now that's been resharpened several times, and this thing has been through hell and back. We even welded an extension onto it to get a little bit deeper, but they work very well. So anyway, I'm going to show you guys how we set this up and drill this. Now, I don't have a vise or anything, plus this would be very tricky to hold in the vise. So what we're going to do is we are going to weld this bar here to get our height. This is a U-channel bar to the table, and then we're going to weld this on a piece of stainless steel square stock, and we're also going to weld that to the table to hold it in place. And then we're going to start drilling. So let me get, first I have to say, anybody who's ever drilled stainless steel knows that it can be very risky, because if you're not careful, you'll work harden it, and then any type of high-speed steel cutting bit, you won't have the chance. You'll have to switch to carbide. And using carbide cutting tools, you have to have a very rigid machine, and which this thing is not. Okay, this is not a milling machine, it's a mag drill. But if we keep our cutting speed nice and slow and keep it nice and lubed up, and to make sure our chips don't turn blue, we want to avoid interrupted cuts. So that means we want to pull a continuous chip as we're cutting it, and we should be okay. So let me go ahead and get this set up, and I'll be right back. All right, so there's our tacked tube, square tube onto our workpiece. We've got 4 tacks on each corners. They don't have to be very big, because this has a significant amount of holding power. that black stuff right there you see is dirt that's inside of the tube that vaporizes and then comes out. So, and also I am not a TIG welder, okay? I just have been fortunate to been around enough very skilled and talented welders to pick up a few tips and tricks. So anyway, let me get this tacked to the table and we'll continue. Alright, so we've got everything tacked up here. It ain't very pretty, but it'll hold, and they're gonna get cut anyway. So now, as you can see here, the machine is still loose. I haven't turned on the magnet yet. So now to make sure that I get a good alignment in the hole, I'm going to turn on the machine and run the cutter backwards. And once it stops wobbling from side to side, I'm going to hit the magnet button and hold it into place. Now, this machine is nice because it has a variable speed on it, so I'm going to turn that all the way down. Turn this on and go ahead and run it backwards. There we go. Bring the tool down into the hole. Okay, nothing's wobbling. And now, turn on the magnet. You can hear the sound change, but we're pretty much lined up. So let me, I need two hands to do this because I got to add oil. Let me turn this off. I have to add oil to the cut. So I'm going to set the phone up here on a holder, and you can watch me go from this probably 4mm hole up to 21mm. And let's see where that is at. It is right there. So let me mark that to make sure I don't overshoot and go to 23, because that would be bad. I'll be right back. All it takes is a little bit of oil. You don't have to saturate it. Just helps draw some of the heat out of the stainless. And like I said, the key thing here is not to get the cut hot. And you want to keep the cutter engaged in the material. So what we're looking for is a flowing chip. There we go. You can see the chip kind of come up like those curly Q noodles. All right, there's the first step. Draw it out. Let it cool a little bit. You want to be really patient when you do this, like I said, because you do not want to work hard in the stainless steel, because then you're done. Then it's game over. You can see that nice long flowing chip. Oh, my phone moved a little bit here. Whoa, sorry about that. I've got it connected to a work light, so we'll keep going here. Real nice and slow. So I'm pulling on the lever just to the point where the drill's about to stop. Now, let me turn it off and show you something here. I'm gonna grab these chips. If you look at the chips, you see how nice and shiny they are? There is no discoloration on them whatsoever, and it's a nice long flowing chip, so we're not getting an interrupted cut. That's what you want. That means the material is staying cool. The feed, or the feed per tooth, I guess you could call it, per cutting edge is ideal, because we're getting a nice flowing chip. We're not getting anything too hot. I guess the biggest thing in doing this is just patience. Do not rush it. And it might be tempting to turn the speed up on the drill to go a little bit faster, but it will turn around and bite you in the butt. So let's keep going. clean the chips off here, and that chirping sound that you hear is not really chatter. Well, I guess it's kind of a chatter, but this kind is okay. You can also hear a chirping sound like that when you use a hand file. But when cutting stainless steel, that usually means that you're pretty good into the cut. So let's keep going here. I got my piece of tape up here marked at 21 millimeters. So let's continue on. I'm gonna bump up the speed a little bit, but not to speed it up, but to give myself a little bit more power. Okay, we are through. We are through, and we're on the last step here. Now, keep in mind, as the hole gets bigger, the surface cutting speed increases, right? Because the radius is bigger. So, again, you do not want to speed it up. Matter of fact, you actually want to slow down a little bit the bigger the hole gets. So the last step is coming right here. Okay, I think we're there, folks. So, geez, let me get the Mitsutoyo out here. Let's see what we got. It's a little bit hot, so it's going to be a little bit bigger. Wow, 21 4/4 of a millimeter. That is pretty darn good for a mag drill. Now the moment of truth, so we should be okay here. Let me find it. This is what's going to go inside, and I kind of cleaned it up here a little bit, but I want a nice press fit, so that way, perfect, look at that. Now if I tap on that or bring it back to the hydraulic press, I can go ahead and press that in there. I have hardly no gap. Well, I have no gap, so then I can just go ahead and fusion weld it. Ooh, that's a little hot. Go ahead and fusion weld it all the way around to go ahead and build the water jacket for the condenser. I'm gonna have to fill up this hole here too. And there's another neat trick on filling up holes. What I use there is, I like to keep a large amount of copper hanging around. So what I do is I'll just lay it on this copper plate and then just fill it in with the TIG weld. And the TIG weld won't stick to the copper, and it makes a really nice finish on this side. And it also keeps it from oxidizing on the back side. And this laser cutting lead-in right here, I need to fill that up too. But that's pretty much it, folks. We hope to keep more videos coming. I mean, I would show you the finished, make a video on the finished product, but it's kind of a secret. And I'm not in the habit of educating the competition. But we're going to try to keep the videos coming of some tips and tricks and some other things we do here at Surefire Engineering to make our world-class, top-quality products. So you guys have a good one. Thanks for watching. Bye. Oh, please like and subscribe. Everybody says that. We don't have any subscribers yet, so we hope to get some with this video. Thanks, folks. Goodbye.